Introduction. Monitoring the level of liquid helium in the device or core state is crucial for conducting cryogenic experiments. Presently, superconductor-based level sensor 1, 2, 3 are widely used for this purpose. The change in resistance of a portion of a lengthier superconducting wire like niobium dipped in a liquid helium device is used as a parameter to estimate the level. While this approach is being widely accepted as a standard method to measure helium level, a simple alternative to this technique is use a thin capillary tube inserted inside the device to sense thermoacoustic oscillation of a liquid helium. These vibration signals are popularly known as Taconi's oscillation 456 and are inherent to closed liquid helium containers wherein a gradation of temperature causes helium vapor to move back and forth at the inner walls of the device. This oscillation could be sensed at the warm end of a capillary tube when terminated with a rubber membrane. The magnitude of this oscillation is known to be higher at the verge of a liquid helium surface.
For A, the sensor of transducer, which converts the physical parameter into an electrical signal. This can be done through various methods such as piezoelectric, capacitive, or resistive sensing. Okay, for B, the signal conditioning process, which modifies the signal to make it suitable for processing. This can include amplification, filtering, or linearization. Next, for C, the signal processing performed by the system, which involves computations or manipulations done on the signal. This can include Fourier transforms, digital filtering, or statistical analysis. For D, the ADC used in the system, which converts the analog signal into a digital one. This can be done through various methods such as successive approximations or delta sigma conversion. Next, for E, the processed signal can be displayed or stored in various formats such as graphs, charts, or numerical values. Okay, for F, if the system includes a feedback or control element, it works by comparing the measured value to a set point and adjusting the system accordingly. Okay, for the last one, wireless transmission and control elements can be present in the system to allow for remote monitoring and control. This can include Wi-Fi, Bluetooth, or cellular communication. These elements contribute to the functioning of the system by allowing for real-time data acquisition and control. That's all.
Illustrate the block diagram of the control loop of the proposed hardware. The purpose of this control system is to ensure a smooth movement of the capillary tube in a linear fashion with a constant velocity. The rotary motion of the stepper motor is converted into linear motion with the help of a converter belt arrangement, moving on the rail with pullers at both ends. The motor was controlled through a driver circuit. The vibration signals sensed by the accelerometer were acquired by Arduino through its 10-bit analog to digital pin and are transferred to the PC through serial communications for automated detection of the LHE level. Control signals to start or stop the stepper motor once the capillary tube reached the predefined leg were programmed in the Arduino microcontroller. The controller was coded in the integrated development environment to complete a set of recordings in the forward and back direction by continuously collecting the data from the accelerometer.
Bill of material. There are many bill of material that use, such as first of all, Arduino microcontroller. a data acquisition module to acquire the accelerometer data and set it to a personal computer for processing the vibration signal for algorithmic identification of the liquid helium level. Second, accelerometer sensor. Sense that reliable measurement of thermoacoustic vibration of a rubber membrane on top of the capillary tube. Next is liquid helium dewar. It offers low liquid helium in assumption and proper venting in any mounting orientation. Next is tapemotor, to handle the movement of the capillary tube in a linear fashion to advance into a withdrawal from the dewar. Next is linear rail. It's to sustain the movement and load of a piece of equipment in a vertical or horizontal direction. Last is rubber membrane, to apply pressure on the rubber membrane to sense the vibration and so vary widely across subjects.
Nextly, I would present about list of the variables. Firstly, we see about magnitude. Magnitude is defined that as use the maximum extent of size and the direction of an object. Magnitude is used as a common factor in vector and scalar quantities. Secondly, we see about frequency. Is the number of waves that pass a fixed point in unit time. Also, the number of cycles or vibration undergone during 1 unit of time by a body in periodic motion. Thirdly, we see about length. Length is defined as the measurement or extent of something from end to end. In other words, it is the large of the two or the highest of three dimensions of geometrical shape or object. Temperature is measure of hotness or coldness expressed in terms of any of several scales including Fahrenheit and Celsius. Last but not least, lastly, I would present about the application of the system. The liquid helium measurement system has a lot of application in our real world, especially for creating magnetic resonance imaging. MRI devices are the primary application for liquid helium in medicine. As a refrigerant, liquid helium is required for the superconducting magnets that are essential part of many of these systems. The quick development of MRI as a diagnostic tool and its potential to significantly improve healthcare in the United States are both attributed to the affordable and readily available helium and the stability of the helium market. Other than that, the liquid helium is also applied in the semiconductor industry.